So, good morning, dear students. Let's continue the topic of the column and start. And today we are going to be see the some numericals based on the Rankine formula and Euro formula also. So, let's see the first numerical and statement of. So, that first numerical is that the statement of numerical is a hollow cylindrical cast iron column is of 150 mm external diameter and thickness is 15 mm, okay, and 3 meter long, and it's a hinge at the one end and fixed at another end. So we have the external diameter of, that external diameter of that column is 150, and the thickness of column is 15. So it means the internal diameter, how much it will be. So thickness means thickness is 115, so it must be both side. So 15 into 15 is 30. So you just minus 30 into 150, you will get the internal diameter of the column, and the length is given, and the bonding hinge condition is also bonding condition is given in the question. So let's find out what you have to be determine or find out on this numerical ratio of Euler's to Rankine load. So first we have to calculate load Euler and then Rankine, and we have to be we have to be give the solution in form of the ratio of both. So for what length the critical load by Euler and Rankine formula will equal? That is simple as. So both formula we have, you just equal to and get the length of the column. That will be the length of the column where the both critical load by Euler and Rankine will equal. So this is a simple concept behind that, dear students. Let E is the given for this question. That E is the the Young modulus of the column materials, 80 10 power 3 Newton per mm square, and A is, you all know that A is the Rankine formula, and is the and sigma E. What's the sigma E? And sigma E is the critical stress induced in that column. This is also given. So we are knowing that Euler formula P is equal to pi square E I L E chi square, and question you might be see that it's a hinge at one end and fix another end. The one end hinge, another end fix. So here LE will be LE is equal to L upon root 2. We all are discussed this condition. So L is equal to L by root 2. So let's first calculate the value of PE. So we have E is the Young modulus given in the question, and L is the length of the column is also given in the question. So my dear students, let's see that pi square EI upon LE chi square, where L is equal to L upon root 2. Okay, so let's we calculate it. The pi square 80 is the E, and I is the pi by 62. This upon L up, that is L is equal to what? L is equal to L upon root 2. So dear student, we have to be no sir, that multiply by root 2 like this. Yeah, 1 upon root 2. Yeah, but 2 it must be multiplication of 2. Root 2 is multiplication of 2. You can see that this it must be L upon root 2. So if you square of this root 2, it's become 2, and it's go up above. Okay, so what happened? So the 2 is missing. So now you can add this. So by this you can find out the Euler load will be 2574.3 into 10 raised power 3 Newton, and if you calculate, if you change in the kilonewton, so it's become like this. Okay, the you know that Rankine formula PR is equal to sigma CA 1 plus A LE K ka whole square. Okay, so so this is the Let's see that you all know that this formula, Rankine formula, PR is equal to sigma C A 1 plus A L E K ka whole square. You all knowing that. So we need to be calculate A is the cross sectional area of the column. So we have this formula pi by 4 D outer का square minus d inner का square. I already explained you how to calculate the d inner. D inner कैसे calculate किया? You can say that di is equal to d inner is equal to d outer is there. So 150 minus 2 into thickness. Thickness is how much? It is the 30. So like this we have calculated that the inner is 120. Okay, you might be understood. So a a is given. A is equal to 1 by 1600 and sigma c is equal to 550. This is given is 550 Newton per mm square. And we can calculate, my dear student, K is the cylinderness ratio, not this radius of gyration. So we have to be calculate the radius of gyration. And that is how can we calculate under root of I upon A. Actually, the formula of radius of gyration, I is equal to, we can say, A K square and A K square. So here we can find this radius of gyration, this I upon A ka whole square. So you can directly use this formula and put the respective value of I and you know that here you already calculated in this way you are written already. So you just write the value of I in numerator and put the value of that denominator value of A and just solve this. So you will get the value K. K is what? K is the radius of gyration. This is 48.023 mm. Let's move ahead. So in the next slide, let's see. Okay. So in the next slide, dear student, we can put all the value what we have get here. So 550 is sigma c, okay, and A is pi by 4, 150 का square minus 120 square, 1 plus A is 1 upon 16, and so this is a length. Okay, so this is a length and this value is what you have calculated right now, what that is a K. Okay, and this is root to come from the AND condition. So अब इससे we can calculate this value of Rankine formula, Rankine crippling load, okay, by the using the Rankine formula. And PE is already we have calculated in, and right now we have calculated the value of PR and do the ratio of both. So we can get 1.633. So for the what? So now the second part of that question is. Second part of this question is, for what length of critical load by Euler and Rankine will be equal? I already told you, just do that. You just equate the both Euler crippling load and Rankine crippling load. Both formula we are knowing, pi square EI upon LE square, and this is also, and put the value of, just do that. So put all the respective value here. We have already calculated it. So put the all value and calculate the value of LE. So once you once you obtain the value of LE is that 5676.52 mm, and that LE you got. So हमको निकालना किसका है? कौन सा actual length we have to find out. This is effective length. So we are knowing that for this boundary condition, LE is equal to L upon root 2. So L is equal to LE into root 2. So just we can calculate the actual length of the column is 8 0.03 10 days power 3, ठीक है, and convert in the meter is 8.03. So that is all the solution of the first problem. This is a one small problem we can discuss right now. So let's the problem state see the problem statement. Calculate the maximum value of cylinder ratio. You just read out the this problem. A ratio of a mildly steel column for which Euler formula is valid, and take E is equal to E is the Young modulus of that material, 210 gigapascal, and critical stress in that material is 330 Newton per mm square. E is equal to 210 gigapascal, and 210 you can that convert into the Newton into mm square. So, and critical stress is 330 Newton per mm square. Simple, we are all knowing this formula of Euler formula. So, we know the Euler formula P is pi square EI upon LE square. And because in this question there is nothing mentioned which condition you should take, so you can assume it. So we can assume first one. So assuming both end hinge, so LE is equal to L. माइट व्यूअर गॉट माय पॉइंट. हमको निकालना है क्या है, सिलेंडरनेस रेशियो. सिलेंडरनेस रेशियो क्या होता है, एल अपान एल, एल अपान के या एल ई अपान के. इस केस में बराबर है, इसलिए एल ई अपान बोल दो या एल अपान के बोल दो. एक्चुअल में दैट इज सिलेंडरनेस रेशियो, वी कैन से द एल ई अपान के. आई माइट बी यू आर गेटिंग माय पॉइंट. So this formula is, and we just break I is equal to a k square. Okay, let's move ahead. So you can see, my dear student, so a, you just send this a upon p upon a, then a it's sent to L by k, so it's become like this, pi square e square L upon e ka whole square and p. So this, my dear student, this value is called sigma c. We are knowing this because we already discussed in the case we are discussing the Rankine formula. So we have to be calculate this L upon K. This is called cylinderness. Actually, cylinderness ratio is LE upon K, but here LE and L both are the same. That's why you must remember this thing. So this cylinderness ratio become क्या हो जाएगा, देखो ये अंडर रूट इसका ये स्क्वायर अपान पाई स्क्वायर ई, एंड दिस टर्म बिकम सिग्मा सी. सो पाई को आप आउट कर लो तो सिलेंडरनेस रेशियो वी कैन राइट लाइक दिस, एंड पुट द ऑल द रिस्पेक्टिव वैल्यूज ऑफ ई एंड सिग्मा सी. सो वी कैन से दैट दिस इज द सिलेंडरनेस रेशियो 79.25. सो ये हमको कैलकुलेट करना था, एंड वी आर कैलकुलेटेड. सो दिस आर द few small numericals which are already came in the RGPB examination in the previous year. That's why I am discussing with you. So this kind of numericals you try to be keep in your practice, so that you will be able to solve such numerical in your examination as well your competitive examination. So that is thing is that you just you need to be remember the all the formula, and as per the need of the question, you must know how it's apply, and you have to be know the each and every element of the formula and what is they are and how they significant. That's thing you know that. So in this way you are able to solve any kind of the problem under this column and study. So my dear student, thank you so much for being here.